Hello, this is Dr. Mears. Today we are going to be doing arithmetic sequence examples. I've had a few requests from students to do different types of examples and to review them again, so we are going to be doing 4 different types of examples, and I really hope this helps you out. Example 1, for each arithmetic progression, write down the value of D and find the term indicated. Remember, the value of D is going to be our common difference. And our common difference can be if we add or if we subtract. We just have to look at the problem, look at the numbers from left to right and see if they increase, which would probably be adding, or decrease, which most likely we're going to be subtracting. So let's look at part A. 4, 11, 8, and we need to find the term indicated, which is u sub 12. So first, let's find the common difference. So what are we doing to get from 14 to 11? We are going down. How many are we going down by? Well, we're going down by 3. Now, if you can't see that and you do want a calculator way of doing it, you take the second term and you subtract it from the first term. And when you do that, you do get a minus 3. So that is going to be our common difference, negative 3. Now we need to find u sub 12. So what we want here is we want the 12th term. This is the first term, this is the second term, and this is the third term. So we are going to be needing this first term, and if we kept going on with this, we need to find out what would be that 12th term. Where would we end up? What number would it be at? So we need what's called the general form. The general form is u sub n equals u sub 1 plus n minus 1 times our common difference. You've seen this before if you were in my algebra class. We used to use the variable a. Now in IB, DP class, math class, it's going to be u. And so we're going to be using this to substitute our numbers in. So we need to find u sub 12. So this is going to be the term that we are looking for. Okay, equals u sub 1, which you could see is our first term, plus our n is going to be our term number, and you guessed it, it's 12, minus 1, times our common difference. Common difference is going to be minus 3. Okay, so now in our calculator, what we can do here is we can substitute in this side. Be careful, we have parentheses here. So we can, in our calculator, clear that out, put in 14 plus parentheses, 12 minus 1 and parentheses, open parentheses. Now this is a negative, so be careful because your negative is down here. So we have negative 3, and then we're going to push enter. And when we push enter, it's going to be negative 19. So u sub 12 equals negative 19. This means that if we went all the way to u sub 12, we would end up at the number negative 19, and that makes sense because we are decreasing. We're going from 14, 11, 8, all the way to negative 19. Now here's the thing, pretty please use your parentheses. Pretty please use your technology. What I'm looking for here when I look at your work, I'm looking at, do you understand what a common difference is? Do you understand the general form? How to substitute your numbers in? Use your technology to get your answer, and then what the answer actually means. It means that if we went to that 12th term, we would land at the number 19. So we can even write that out. The 12th term is negative 19. And I wrote it like that so that you see this is the 12th term. Okay, it's not 12, it's in the 12th term we would land on negative 19. Okay, so for part B and part C, I would say hey, pause here, see if you can try it, and then come back to the video. Hopefully you try this. Okay, part B, what we're going to be doing here, we're looking at the sequence 2, 7, 12. I see that we're increasing by 5. You could do 7 minus 2, which is an increase of 5, so that is your common difference. We need to use a general form. We need to find u sub 9, so the 9th term, what would that be? And so I'm going to write down the general form. If you're having trouble substituting in numbers in, I highly suggest rewriting the general form and then substituting in the numbers from the problem. So we're looking for the 9th term. Our first term, u sub 1 was 2, plus the term number is 9 minus 1 times our common difference, which is 5. So now in my calculator, I am going to put this side in. So I'm going to bring it over here, clear it out. So I'm going to put 2 plus, using my parentheses to the best of my ability. I see I have 2 plus 9 minus 1 times 5, and that's what I have here. Press enter, and I get 42. So my ninth term is positive 42, which again makes sense. We started at 2, we are increasing, so we do come to a bigger number, which is 42. Part C, what are we going to be doing here? We're going to be adding 2. Again, you could do negative 5 minus a negative 7. Be careful because that is negative, and so that does give you a positive 2. Common difference is 2. U sub n equals u sub 1 plus n minus 1 times our common difference. We're looking for the 21st term. Our first term is negative 7. Our term number is 21 minus 1 times our common difference of 2. We're going to substitute that side into the calculator, and we are going to get 33. So the 21st term is 33. You may pause here. If you are in my class, you can ask me questions. We're going to be going to example 2 now. If I could get the paper. There we go. Okay, example number 2. Given an arithmetic sequence in which u sub 1 equals 14 and d equals 3, find the value of n such that u sub n equals 2. So what we have here is we have our first term, we have our common difference, we have to find a missing variable. We also have where we would land. We land at the number 2, so that's our u sub n. So what does that look like? Well, let's use our general form and substitute the numbers in so we can see what the equation looks like. So u sub n, do we have that number? Yes, they gave it to us. It's 2. So I'm going to put it underneath u sub n. So whoever u sub n is, I'm going to put the 2. Bring down my equals. U sub 1 is 14 plus n. I don't have n, so I'm going to just write the letter n, minus 1 times common difference, negative 3. So here it now becomes a problem in which we need to solve for n. In solving for n, there are many different things you can do. You could pick a number and guess and check. Go for it if you would like to. You need a number that you put in here where you can come out with the number 2. Guess and check all you want if that is the way you'd like to go. However, when we get into more complex problems, guessing and checking is not going to be the way to go. It's just going to take a longer time. So I'm going to show you 2 different ways of solving. Are there more? Yes, of course, there are more ways to solve. There's even applications to solve for you. However, it's important to know how to solve an equation, especially in DP math. Okay, so we have to solve for n. Here are 2 separate ways. Whichever way you would like to use, you can. If you have a new way of solving, come and show me, just so that we can make sure you are adhering to the rules of algebra. Okay, so this is the first way to solve. I'm going to rewrite the problem. The first way, well, we're going to be starting off this way every time. We have to subtract this 14 from both sides of the equal sign. This 14 is being added to the variable situation going on here. It is a positive number. To undo it, we have to undo plus, which means we have to subtract it from both sides out. These need to be opposite signs when you're doing addition and subtraction. 2 minus 14 gives us a negative 12. Okay, here's where the ways kind of separate. So for this way, I'm going to be using the distributive property. Some already saw it where we're going to be distributing our 3. So we're going to be doing negative 3 times positive n. That's going to give a negative 3n. Negative 3 times negative 1 gives you a positive 3. Be careful with your signs. This equals, I'm bringing down the equal sign and the negative 12. Now becomes your two-step solve. We worked a lot on this in algebra. We have to subtract 3 from both sides. Do the addition subtraction first. Opposite signs, they can cross out. I now brought the 3 over to the other side. Negative 12 minus 3 is negative 15. Bring down your equal sign, 3n. This is linked by multiplication. We need the inverse. So instead of multiplying, we are going to be doing the inverse, which is division. That cancels out the 3. So we're isolating our variable. We're getting our n by itself. So we cross that out, so we find n is going to equal 5. So what value of n? What value of n? It's going to be the term number is going to be 5. So this is the term number, the term number. That's what we actually solved for. Now, or, you can see it another way. Let's write this down. 2 equals 14 plus n minus 1 times negative 3. Okay. So we still start the same way. We got to get that 14 out of there. It's just hanging out, linked by addition. It's positive. Let's subtract it. So we're going to get negative 12 n minus 1 times negative 3. So we're back at this game point here. Instead of distributing, you can get rid of the negative 3 quickly. It is linked by multiplication. When we have two parentheses next to each other, that means multiplication. We could divide it first out. So we don't really necessarily need the distributive property, so we can divide it, so we can bring it over to the other side. Negative 12 divided by negative 3 is 4. Bring down your n minus 1, and then we can add 1 to both sides. You could do that. We still get the same answer, 5 equals n, that is the term number. So either way you want to do it, whether you want to distribute the 3, distributing just means multiplying it if you want to multiply the 3, or if you want to divide by the negative 3. Multiply by the negative 3 or divide by the negative 3. Either way, you're going to get the same answer. Are these the only two ways of doing it? No, there are other ways. Come and see me if you discovered another way, and we can see if it adheres to the rules of algebra. Hope this helped. Okay, this was example number 2. Let's go on to example number 3. Example number 3. We have to find the number of terms in the following finite arithmetic sequence. Now remember, finite means that it stops. So if you notice, we do have the dot, 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 and then it stops. So find the number of terms. What does that really mean? That means if we went, this is u sub 1, sorry, let me start over. This is u sub 2, this is u sub 3. We have no idea where it stops. What number is this? Is this u sub 5? Is this u sub 14? Like where does this stop? We don't know. What number, what term is the number 36? What term number is that? So in order to do this one, let's again write down our general term, our general form. And notice I keep going back to this. Are we going to be using it a lot? Yes. Did I forget my 1? Yes. Am I erasing it and making everything shake on the desk, especially the camera? Yes. Okay, so here we have, put my 1 in. All right, perfect. Now we have a correct general form. So let's substitute in what we have, okay? I definitely know we have the first term, so I'm going to put my equal sign down. I know I have that. All right, negative 8 plus, okay, we don't know the n, minus 1. Do we have a common difference? You know what? We can find one, so let's find a common difference. Our common difference is going to be plus 4, plus 4. Again, take the second term, minus a negative 8, the first term, and you're going to come out with positive 4. So I have 4. Okay. Do we have a u sub n? Do we know what number we end on? Yes, we know what number we end on. We just don't know that term number. So this is very similar to example number 2. In example number 2, I just gave you the information in a different way. Example 2, I gave you the information by labeling everything. In example 3, I gave you the information as a sequence and you had to find the information. We use the same general form. We are using substitution. We substituted all of the numbers that we had. And now, yes, we have to solve for n. So any way that you wanted to solve for n in that last problem, why don't you pause the video and try solving for n now? If you're having trouble solving for n and you're sitting in my class, please call me over and I can help you out in any way. What I'm actually going to do is, hopefully you're back, I am going to show you the solving process without me talking you through it. So if you need me to talk you through the process, then you can rewind this video. But here is the process. So this first process, I multiplied, I distributed the 4. The second process, I divided by 4. And that's the difference. Here I distribute, which means I multiplied by 4. And here I divided by 4. Divided both sides of the equal sign. So one side of the equal sign, other side of the equal sign. This I just distributed to this side. Did I get the same number? Yes. Can we answer the question? Yes. And the answer to the question is, well, how many terms? So this is u sub 12. So there are 12 terms. Oh, there goes my lights. Let's turn them back on. You know, when the lights start going off, then video should be wrapping up, which means that we are not on example 3 anymore. We are on example number 4, our last example. Okay, so I had a few students who came to me and said, we're having problems with this example. Can you give us a general way to always find the answer without having to guess and check this type? And I said, yes. So this is for the students that came knocking on my door. Example number 4. All right, 2 terms in an arithmetic sequence are u sub 6 equals 4 and u sub 11 equals 34. We need to find u sub 15. So let's just map this out. We don't have u sub 1 or u sub 2 or u sub 3 or u sub 4 or u sub 5. We do have u sub 6, which is 4. Okay, yay. We don't have u sub 7, we don't have u sub 8, we don't have u sub 9, we don't have u sub 10. We do have u sub 11, which is 34. All right, and they want us to find all the way to u sub 15. That's what we're finding. So we don't have u sub 7, 8, 9, or 10. Put some commas in there. And what I'm doing is I'm visually showing you what it looks like where we don't have some of the terms. They gave us a middle group, but you know, we could guess and check because we're going to need to find some information. And you're also visually seeing where we need to end up. So first, let's look at our general form. Okay, do we have u sub 1? No, we don't have u sub 1. I don't think we can get it, but I don't think we're not going to really need it right now. We could say that we started here. Do we have a common difference? No, we don't know the next numbers. So this is tough right now to use this. So we can't use this yet. What we do have to find is, we do have to find this common difference, and that's going to help us get to that u sub 15. So that's first. So find the common difference. And this is where you can guess and check. You can try to add 5. You can try to add 8. You can try, because we know we're going from 4 to 34, so we are increasing. You can try to add whatever number, to get to 34. That works. So the first way is guess and check. Will it take a while? Yes. Will it work all the time? Well, it might take you a long time. So is there a surefire way to do this problem without guessing and checking? Yes. Or here's what I'm going to say. Here's the thing. So stick with me. We have u sub 6. U sub 6 is 4. We have u sub 6. Okay. Plus, how many times do we have to do our common difference? So how many times are we going to have to add the same number? So we're going to have to add here 1. We're going to have to add here 2. We're going to have to add here 3. We're going to have to add here 4. We're going to have to add here 5. So how many times do we have to add the common difference? 1, 2, 3, 4, 5. So we're going to have to do 5 times the common difference. 5 times the common difference to get from 4 to 34. Remember, adding and multiplying is repeated addition. So if we have to add 5 times, that's 5 times the difference. So adding 5 times, add 5 times is 5 times the common difference. Multiplication is repeated addition. Okay, so if we take u sub 6, 4, and we added 5, a common number 5 times, we are going to get to the number 34, or we're going to get to u sub 11. What does this look like? Let me read now that you have a little formula, let's put the numbers in. You start at 4, u sub 6. You add 5 times the common difference, 1, 2, 3, 4, 5, to get to the number 34. This will always work, but now it becomes a solve problem. Solving it, again, minus 4 from both sides. 5d equals 30. 34 minus 4. Divide 5 from both sides. Our common difference is 6. Positive 6, which means we're going to be adding 6 5 times to get to 34. And it does work. Here we have 10, 16, 22, 28. It works. You can check it out. This will always work. Okay, but we still have to find, now that we found the common difference, yay! We still have to find the 15th term. Okay, what is the 15th term? So, let's do it. We can go back to u sub 1 so that we can find what u sub 15 is. I'm wondering if we can actually go from u sub 4. So you might want to try, and this is what I'm going to put out to everybody in the land, you might want to try making I'm wondering if u sub 6 could become u sub 1. Now, if I lost you, don't worry. Please don't worry if I lost you. I just want to see if that would work. It might not. We'll find out. Okay, but what I want to do is I actually want to use this and its correctness with our u sub 1. So what we are going to do is we have to find u sub 1. So let's go back and let's find u sub 1. So how are we going to go backwards? What are we going to do? Well, let's subtract 6. And we can keep doing that in our calculator. We come out with negative 2 minus 6, negative 8 minus 6, negative 14 minus 6, negative 20, negative 26. Wow. Okay. So here we have u sub n. Oops, what are we looking for? 15. Equals 15. Looking for that one. Negative 26 plus our n, 15, minus 1 times our common difference of 6. Let's put that in the calculator. Negative 26 plus 15 minus 1 times 6. 58. Let's check to see if that works, okay? So I'm saying right now this is going to be 58. So let's see if that works. How can we check? Well, we just need U12, U13, U14, and then we're at U15. Could you? Yes, you're saying in your head, Mears, you could have just kept adding 6. Yes, everybody. And that's what I want you to realize. We could have just used our common difference and kept going. So 34 plus 6, 40. 46. 46 plus 6, 52. 52 plus 6, 58. Does it check out? Either way we do it, yes. Would it be easier to just add 6? Absolutely. But you know what? Now you know how to get to that first term. Use our formula. Here is your nice formula to be able to find out common difference anytime. I hope this helped. Ran a little long. This is Dr. Mears. Thank you.